Hey guys, my name is Jay and I'm working with Reeve and Neha, and today we'll be talking about urban green spaces and if they're biodiversity havens or ecological traps. Enjoy!
Urban green spaces are areas within cities and towns dedicated to vegetation and nature, including parks, gardens, forests, green roofs, and water bodies like ponds and lakes. These spaces can range from large, expansive public parks to small community gardens or green corridors that connect urban areas to the surrounding natural landscapes. It has been well documented that these spaces provide benefits such as improved physical health, mental benefits, aesthetic values, and places to go to escape from the city for those who choose to use it. However, how do these spaces impact plant and animal populations? This is the reason that we chose to explore this topic, because of the visual impacts of green spaces in Camrose. For example, what were the underlying drivers leading to the domestication and coexistence of deer populations in Camrose? As cities continue to expand, urban green spaces such as parks, green roofs, and community gardens are being integrated into urban landscapes to foster biodiversity. These spaces are often seen as vital refuges for species in otherwise highly urbanized environments, where natural habitats are increasingly scarce. However, their effectiveness in supporting biodiversity remains debated. A critical question arises. Are urban green spaces truly biodiversity havens, providing critical habitats for species? Are urban green spaces truly biodiversity havens, providing critical habitats for species? Or do they sometimes function as ecological traps, luring species into suboptimal or harmful environments? Urban green spaces have been shown to increase plant biodiversity, which offers significant environmental benefits. These include mitigating the effects of climate change, absorbing air pollutants, and producing breathable air. Additionally, urban greenery helps to reduce the heat island effect through evapotranspiration and protects water resources by absorbing and storing water and preventing urban flooding. Beyond plants, urban green spaces can positively impact animal populations, especially when they are well designed and managed.
Research highlights that gardens with diverse microhabitats tend to have higher species richness and abundance of moths. Similarly, large, well-connected green spaces support higher biodiversity. For instance, birds in cities may require up to 35 hectares of continuous green space to thrive. Well-vegetated parks provide critical resources like food and shelter for urban bird populations, while green roofs and community gardens attract species that would otherwise avoid dense urban areas. Studies also show that urban green spaces with high plant diversity and structural complexity support a wide range of bird species. In cities like New York and Singapore, carefully planned green spaces have helped maintain healthy bird populations and attract migratory species through the use of native plants. Connectivity between green spaces is crucial for allowing gene flow between urban wildlife populations, as shown by studies of narrow green corridors like the Long Island Motor Parkway in New York, which increase genetic connectivity between populations of white-footed mice. Urban parks and gardens also support higher densities of pollinators and amphibians, particularly in areas where natural habitats have been fragmented. Pollination studies indicate that plant-pollinator interactions are more robust in larger or brighter habitat patches, reinforcing the importance of high-quality urban habitats for sustaining pollination services.
Despite their efforts, urban green spaces can sometimes act as ecological traps, drawing species into environments that fail to meet their survival needs. For example, while urban parks may attract bird species, reproductive success may be hindered by predation, pollution, and competition from invasive species. In other cases, isolated parks and green roofs may lack sufficient food or nesting sites, leading to population declines. Species with specialized habitat requirements are particularly vulnerable to ecological traps. These species may be attracted to urban green spaces that appear suitable but lack the necessary resources for long-term survival. Pollution and human activities in urban areas further reduce the suitability of green spaces as wildlife refuges. Fragmentation of urban habitats also plays a significant role in the decline of biodiversity. Poorly connected parks in cities like London and Los Angeles have seen several declines in bird diversity, with native species being replaced by adaptable generalists. Additionally, the concentration of predators like corvids in urban green spaces can increase nest predation for songbirds. Artificial light pollution in cities disrupts the behavior of nocturnal species such as moths, increasing their susceptibility to predation. Invasive species pose another risk in urban green spaces, particularly private gardens. Non-native plants, often introduced from authentic resources, can outcompete native species and reduce biodiversity. Similarly, domestic cats, common in urban areas, are a significant threat to bird population and other small wildlife, turning gardens into hunting grounds that further disrupt the urban ecosystem.
Urban green spaces play a complex role in biodiversity conservation. While larger, well-connected green spaces tend to serve as biodiversity havens, smaller, fragmented, or poorly designed spaces are more likely to act as ecological traps, attracting species into suboptimal habitats. To effectively conserve biodiversity, urban planners must consider the size, quality, and connectivity of the green spaces, ensuring they support a diverse range of species and avoid becoming environmental sinks.
We believe that future implications for urban green space research should be focused around understanding how urban green spaces can be better integrated into existing city infrastructures to maximize ecosystem services like stormwater management, carbon sequestration, and biodiversity support. Research should also focus on optimizing green space connectivity to prevent ecological traps, ensuring that species can move freely between habitats and maintain healthy populations. Further investigation is needed into the long-term effects of green space fragmentation on wildlife gene flow, particularly for species sensitive to an urban encroachment. Also, researchers should focus on studying how a habitat degrades into an ecological trap in urban settings, as well as how the types of infrastructure surrounding urban green spaces impact individual species. Finally, exploring which plant and animal species are most adaptable to urban and climate stressors will be essential for future urban planning to ensure that these spaces continue to provide vital environmental and social functions as urban areas continue to expand.
Furthermore, management is integral to ensuring that biodiversity havens stay as biodiversity havens and don't degrade into ecological traps. Effective urban planning is essential to maximize the conservation potential of green spaces and prevent the unintended creation of ecological traps.